Hey guys, thanks for joining us today. We will be talking about patterns, the blueprints of software that you can apply on very different projects if the task, is similar. Monica will tell us today about the most popular patterns that, every Java developer should know. As always, I remind you that you can ask your questions in the chats. We will try to cover all of them. If you like the light talk, press likes and subscribe. And yeah, without further ado, I'm passing over to Monica.
Yep, thank you. And hello, everybody. Thank you for joining again. And today we are going to be talking about the design patterns. But before that, let me quickly introduce myself. So my name is Monica, and I'm a senior software engineer at EPAM. So actually, I perform the key full stack developer position on external project, and my main technology stack consists of Java of different versions, Spring Boot, AngularJS, Node.js, and other frameworks like Hybris, GraphQL, Azure Cognitive Search, Schema Cloud Serverless Functions, and others. Let's go quickly through the agenda of today's presentation. First of all, we will try to figure out what's the general concept of patterns themselves. Then we'll have a look at their classification. After that, we'll deep dive into the design patterns, and then we will go through some most popular patterns from creational, structural, behavioral groups, and then we'll conclude on that. So yeah, let's proceed. What is the pattern itself? So pattern generally refers to a recurring and recognizable solution to a specific problem or challenge. So pattern can be considered like a template or a blueprint that provides a structured or proven way of solving common issues in software development. But you can ask, what are benefits of patterns usage? So first of all, it's reusability. That's like a common way of solving some specific software development tasks. So they are encapsulate proven solutions to common problems. And then that's definitely maintainability, because pattern promotes structured and organized code that is easy to maintain and extend. And if changes are needed, we don't have to refactor the whole code base. We just have to change a specific place and localized, depends on specific pattern implementation. Besides that, patterns ensures scalability of projects, so they often lead to more flexible and extensible code architectures. Therefore, makes easier to add new features and adapt code to changing requirements without general big refactoring. After that, patterns can help to solve performance issues in the code. So, for example, there are some patterns that designed to improve performance of resource utilization in memory, like caching or lazy loading patterns. And these optimizations can lead to more efficient software. And besides that, the code understandability. So if we are using patterns, the code becomes more predictable, easy to read for other developers, and therefore anyone who needs to work on maintain code can easily understand it. What is the general classification? So patterns differ by their complexity, level of detail, and scale of applicability, and they are divided into multiple categories based on that. For example, there is a architectural patterns group that define the high-level structure and organization of a software system. So these patterns guide how components and modules interact with each other in applications. So, for example, most popular one is MVC, microservices, service-oriented architecture, and others. Also, there is a concurrency patterns group. That's patterns that deal with multi-threading environment, and they ensure that they provide some solutions for synchronization, coordination between multiple threads or processes. So here we can see that there is a mutex, semaphore, read-write log, critical section, producer-consumer, blocking queue, and others. And design patterns. These are recurring solutions to common problems in software design. This provides like a blueprint for structuring code to achieve specific objectives. And definitely there are other groups, but we will deep dive into design patterns. So they are typically classified into three primary categories based on their primary purpose. So first of all, that's the creational patterns that provide object creation mechanism that increases flexibility and reuse of existing code. Next group is structural patterns that explain how to assemble objects and classes into larger data structures and keep these structures flexible, efficient, and straightforward. And behavioral patterns, they take care of effective communication between objects and their responsibilities. Well, let's get started with the creational patterns group. So in scope of this group, we will look at builder, factory method, and singleton patterns. So the builder pattern solves the issue with large number of optional parameters in constructor. So this constructor is called like telescopic constructor, and it can lead to inconsistent or broken objects in case we have multiple parameters. It then can be easily mixed up. So for that, we can use the builder pattern that will provide the object step-by-step solution. Therefore, developer can easily create objects without any breaks and can easily maintain it. So here I would propose to look at its realization. All right. So here we have two examples. First one, that's the realization of class computer. So here we have like required parameters that are mandatory to create computer class. And we have also optional parameters that have a default value in case we do not set them up. Besides that, some getters, setters, and we have a private constructor that consumes a computer builder static class that is reflected below. Let's have a look at it. So in this class, we have this static computer builder, and it also contains required parameters, optional parameters, and we can see that there is a public constructor computer builder that consumes two mandatory parameters that will be definitely set up. And also we have two set methods for optional parameters that can be used based on necessity. So we can use it or we can just skip them, therefore default value will be used. And in the end, we have a build method that calling the computer constructor in the current class and sending the object of builder inside. So if we will look at this constructor, so it consumes computer builder, and from this computer builder, we are extracting all fields that set up or taken as default, and therefore returning back the computer object. But in production, generally, we use the Lombok dependency, which provides a more straightforward and easy way to implement this pattern. We've just set in the builder annotation under the class that we want to use with builder pattern. We just have to define required parameters, and for default parameters, we have to just set up the builder.default annotation and set up the default values. So actually, yeah, this way is more easy and clear. It's like out of the box implementation that can be used. Then we can move on. And the next pattern that we'll look at is factory method. So factory design pattern is used when we have a class hierarchy and we want to deal with object creation from the same hierarchy. Let's say we have like hierarchy of 3 classes and we want to manage the objects creation based on specific parameter that we send. So therefore we are encapsulating logic and making an abstract level and just creating responsible class for that, which is factory itself. Let's have a look at example. So here we have an abstract class computer with abstract methods, get RAM, HDD, CPU, and we have the realization of this computer abstract class. We have, for example, personal computer with all these parameters and realization of abstract methods. And then we have a server computer realization, again, the computer class with realization of abstract methods. And we have a computer factory that contains the method getComputer. And here we are sending all parameters that are necessary to create a computer object. But besides that, we are setting the type of computer that we want to create. So let's have a look. We have an option PC computer type and server computer type. Based on the type that we are sending, we will return back specific type of computer, and we are setting up the parameters that we also send to this static method. Therefore, a specific class from the same hierarchy will be created and returned back to user, and the logic of deciding which object we want to create for the same hierarchy is contained here. And all that we need to use that the specific type of the class that we want to create. All right, that's actually realization of the factory methods design pattern, and then we can move on to one of the most popular SingleTon patterns. So that's the pattern that ensures that just one object of class will be created while runtime. And we can have a look at a couple of implementations. So first of all, let's have a look at basic one and try to understand the concept. So to create a SingleTon, we have to define a public static variable in some class, which is instance. In the beginning, we can set the null value for initialization. And we have to define a private constructor. So we are restricting this constructor from internal usage. And we have a public static getInstance method that will call constructor inside. So this logic is encapsulated here. And here we'll have a check if instance is null. So for the first time it is null. So then we will create this object of class and we'll put to this instance. And all next cases when we want to reach this SingleTon object, we will skip the if block. It will just return the value of this object. So actually this approach is called like lazy initialization because we do not create object right when application starts. We are just creating based on necessity when we call this getInstance method. Let's see. And here we can have a look at next implementation, which is SingleTon thread safe version. So here with this SingleTon, we can work in multi-threading environment safely because for that we have added the synchronized block. Therefore, this part is critical section for threads. It ensures that just one thread will reach this section, and therefore we won't need to deal with broken objects that are partially created for other threads or just creating SingleTon twice. So we are safe with that. And besides that, for this kind of SingleTon, we are using volatile keyword. That means that we are making this variable visible for all threads. We are moving it from thread stack to the memory heap space. And finally, that's the last implementation of SingleTon, which is enum in Java. So actually, the main difference with SingleTon lazy is just that when we create the enum SingleTon, it will be always created. It doesn't matter do we use this enum or not. So that's like eager fetching approach. But for SingleTon lazy, we will just create it when it's required when we call this method. That's the key difference between those two implementations. All right. And with that, we can move on to the next group, which is structural patterns. So in scope of this group, we will look at decorator, proxy, and bridge. So first of all, let's have a look at decorator pattern. So this pattern is used to modify the functionality of an object at runtime. So at the same time, other instances of the same class won't be affected by this. Let's have a look at the example. Structural decorator. All right, so we have an interface car with a method assemble, and we have a basic car. That's the realization of this interface. Like we are just overriding method, setting some logic here inside, And we also have two classes, which is luxury car and sport car. Luxury car extends a car decorator. Sorry, let's go quickly through the decorator first. So we have a car decorator, which also implements car interface, and it's it contains the car as a composition inside. Therefore, since we are implementing car interface, we are overriding method of this interface. In this method, we are calling the same method on the object that is encapsulated here. So that's the composition. And for the luxury car and sport car, we are extending this object from the car decorator. And if we want to create this kind of object, so we are sending car object inside that is coming to super. And here we can see that we are implementing method assemble from the super class. And first of all, we are executing existing logic. After that, we are adding additional logic. So we are decorating this by specific one based on the specific class for luxury car. We are adding specific additional logic, let's say. So that's actually decoration. And the same we have for the sport car. So besides, we're not just executing core logic from super assemble method, but we are also like adding additional one that we want to apply. And that's the actually how we can achieve the wrapping some specific logic by adding additional implementation overhead while runtime. So with that, we can continue and proceed with proxy. So proxy pattern provides a placeholder for another object to control access to it. In other words, this pattern is used when we want to provide controlled access to functionality. Let me explain it probably in a different way. So by looking at example. So here we have again the interface of some expensive object with method process inside. Then we have its realization with implementation of process method. And then we have proxy. So here we can see that we are encapsulating that's the composition that contains the object inside. And we also, since we are implementing interface, expensive object, we are realizing method process. And in this method, we can see that we are using the implementation from our composite, let's say. And besides that, it is also, let's say, wrapped somehow by additional logic overhead. So it is pretty similar to decorator, but difference that we are using composition here, but for decorator, we are using inheritance. And since there is this difference, there is a key logical difference between these patterns usage. So since here we are using the composition, we can realize the lazy initialization approach with this pattern. So like in this example, to access the expensive object, first of all, we are checking if it's created. If not, we are creating it. Then we are returning it back. Otherwise, it is null and we don't create object without necessity. So this approach, again, is more beneficial in terms of memory saving. But for decorator, it is not possible to realize since decorator consumes already created objects. So we cannot control like creation of this object, and therefore we cannot realize lazy initialization here. So it just eager fetching approach. So, and for proxy, it's the lazy approach, which is possible here. That's an important point. And with that, we can go back to the presentation and have a look at the last pattern in this group, which is bridge. So the bridge pattern is a structured design pattern that separates an object's abstraction from its implementation. So if we have two separate class hierarchies, one for abstractions and another for implementations, we can easily deal with classes from different hierarchies by using bridge pattern. Let me show that an example. So let's have a look. We have a first hierarchy, which is color. Here we have interface color and method apply color. We have its realization, green color that implements color interface, and there is a method realization for specifically this class, and there is a red color implementation also. And let's have a look at the second class hierarchy, which is shape. So here we have an abstract class shape, and it contains inside the composition color, right? And so we are sending this to the constructor while creation shape object, and this will be set up in this protected color variable. And we have realization. Since it's abstract class, it is not possible to create it. We will, of course, have realization of the shape class. That's, for example, triangle. So here we also have a constructor that consumes a color object from different hierarchy and put it to the super constructor of this class. And we also have a apply color realization overriding. So here we also have like method we are calling from the our composite that we send the constructor parameter, and besides that we are again adding our implementation overhead. The same we have for pentagon. So we're also sending the parameter color class from totally different hierarchy. It is coming to super constructor. Here we are setting up as a composite for this abstract class. And then in pentagon, we also have apply color realization, where we are calling method on color that we send in parameters and just wrapping it with additional logic that's specifically valid for this class. Therefore, we are combining two completely different classes together, and it is also it is also like a bit similar to proxy or decorator, because in this specific part we are again like decorating or adding additional logic over existing one that we want to have. All right. Then the last group of patterns that we are going through today is the behavioral patterns. So here we will look at template, method, state, and strategy. Well, the first one, template method. This pattern is behavioral design pattern that defines, let's say, an algorithm of actions that will be available for subclasses, and some of those actions will be available for change. Therefore, we have like specific skeleton or algorithm that children classes will follow with some possible adjustments. Let me show you that in example. All right, let's have a look. We have a house template abstract class, and inside of this class, we have a public final void build house method that contains like a couple of actions that are executing one after another. And as we can see, build foundation method is realized here in this abstract class. The same for build windows, because if we want to build house, foundation and windows will be built in the same way. It doesn't matter which kind of house do we want to build, right? And if we will look at the example of realization glass house, so here we can see that we are implementing just two methods that will be having specific implementation based on this house type. So if you go back to the house template abstract class, here we have two abstract methods that are supposed to be realized in children classes, because this should be specific based on the type of house in our case that we want to create. So let's go back to glass house. So here, as we can see, we are implementing these build walls and build pillars specifically from glass, because it is valid for this current domain class. And the same, we have wooden house that also extends house template, and it overrides two abstract methods from its parent by like adding some specific implementation, which is valid for this specific class. So these methods that we override in specific classes are called hooks. And therefore, we can create, based on this house template, glass house or wooden house. And they will have like a couple of methods that are same and a couple of methods that were abstract that we adapted, let's say, to specific class domains. That's what is template method about. The next pattern that we'll look at is state. So the state design pattern is used when object changes its behavior based on its internal state. So if an object has specific limited amount of states, the pattern can be applied perfectly fine in this case. And let me show you an example then. So to implement this pattern, we have to introduce an interface. In our case, it's state with some method do action. Then we have realization of this interface. For example, TV start state that implements this interface, and do action method is realized based on this class name, like TV is turned on. The same we have for TV stop state. So we have two states, and the amount of them are limited. And also we have a TV context that contains state inside. That's therefore, and also implementing the state interface. So the important point here that we are storing current state of the object in this class is a composition again. And we can see that since we are implementing interface, we are overriding its method do action, and in this method we are calling do action method from the state that is encapsulated in the scope of this object. So that's again composition works, and it is pretty similar to proxy pattern and other that we went through. Yep, and sorry. Then we can move on to the next one, which is strategy. Strategy pattern is used when we have multiple algorithms for specific task, and client decides the actual implementation at runtime. So again, pretty similar pattern to state and others, like proxy and bridge strategy. Okay, so yeah, to implement strategy pattern, for example, we have an interface with some method inside. We have implementation of this interface. For example, we have PayPal strategy and credit card strategy, right? And for example, we have a shopping cart with public void method pay that consumes a payment strategy. And based on this payment strategy that we got, we're executing specific method on it. Let's see. So here the difference with a previous pattern is just that we do not store this payment strategy in this class. So it is without the composition. So we're just taking method that coming to us, and we're just calling method on it. Pretty similar, but without composition, without storing the state of the object that we send. And if you look at example, so for example, we have a shopping cart, and we can create the payment strategy PayPal, and we can just send this strategy to the pay method. And the same we have for the credit card. For example, it's the name, card data, and we can send this strategy again to the card to pay for something. All right. And that was the last pattern from this group. Thank you very much for listening and for your attention. And seems like we can conclude on that.
Yeah, before going to questions, I will give you like 1 more minute to ask your question, and it's my default 30 seconds of commercial. As always, I remind you that we have free Java online school, MJC School, that covers everything that a junior developer should know, starting from the way to write the main methods and up to Spring framework, clouds, front-end technologies, basically everything. And it is absolutely free on MJC.school. That's all with the commercial. Thanks for listening to it. And regarding the question, yeah, we have one. How to use factory in case class hierarchy contains more than 2 children?
All right, so it does that. I have shown an example when we use like class hierarchy with 2 children, but in case of multiple children, we will use like switch component instead of like if-else blocks. That's the difference that will be implemented, and everything else is stayed like it is. So yeah, just in case of multiple children, the switch will allow us more options, multiple options than like just usual if-else with 2 possible options to choose.
Yeah, and a few days ago, Java 21 was released with new enhancements to switch statement. If you're interested, you can check out our video on Java 21. Okay, I don't see any more questions for now. I hope, Maria, that answered your question. And yeah, I think we will be wrapping up. Thanks, Monica, a lot. It was a great talk. Thanks, guys, for joining us today. And well, see you next time.
Thank you.